Hello everyone, welcome to my YouTube class. In this video we will see what is a leader of an array and we will write the program to find the leaders of an array. Now an element is called leader of the array if there exists no element greater to it on the RHS subarray. Now what does it mean? Let us take this as an example: 16, 17, 5, 3, 6 and 2. Now we will find whether 16 is leader or not. Now let us check, is there any element which is greater than 16 on RHS subarray? Yes. And what is that element? 17. Therefore 16 is not leader of an array because there exists an element greater to 16 on RHS subarray. Now is 17 a leader of array? Is there any element greater than 17 on the RHS? RHS means I have to search at index 2, 3, 4 and 5. This is the RHS of 17. And you don't find any element greater than 17 in the RHS subarray, therefore 17 is the leader of an array. Now let us see 5. Is there any element greater than 5 on the RHS subarray? RHS subarray means 3, 4 and 5. Yes, there is an element which is greater than 5 on the RHS subarray, that is 6. Therefore 5 is not an leader of the array. Now let's take 3. Is there any element greater than 3 on the RHS subarray? Yes. And what is that element? 6. Therefore 3 is also not the leader of an array. Now let us see, is 6 the leader of an array? Is there any element greater than 6 on the RHS subarray? No greater element greater than 6 on the RHS subarray. Therefore 6 is leader of an array. Now let us take 2. There is no element greater. There is no element on the RHS of 2. That means there is no element greater than 2 on the RHS subarray. Therefore we consider 2 as the leader of the array. We notice one thing, that the rightmost element is always the leader of an array. Now I want you to pause the video and think, how do we solve this particular problem? Thank you. Now let us see how do we write the program to find the leaders of an array. Now we start writing the program and I can start with hash include stdio.h. Okay, then we write here int main. What is the input for this program? The input for this program is you need an array and you need n elements of an array so that you can find the leaders. Therefore let us declare an array and I say int a of 100. Now whenever I declare the array int a of 100, what will happen? An array will be created in the main scope of the RAM. Is that okay? Now let us assume that this is the main scope and an array is created. What is the array name? Array name is A. How many elements are there? 100 elements are there. 0, 1, 2, 3, 4, 5 and so on up to 99. 0 to 99, 100 elements are there. And do we want to store all 100 elements? No, we can store less than or equal 100 elements. Therefore, how many array elements we want to store? Let us write in some variable n. Now, what does n represents? N represents how many array elements you want to store. If n is 4, we want to store 4 elements. If n is 6, we want to store 6 elements and so on. Now what is the value of n to begin with? It is garbage. Therefore it becomes essential for us to read the value of n and we say scanf %d %n. Now read the value of n. Let the value of n be say 6. That means 1, 2, 3, 4, 5, 6. 6 elements we want to read. And how do we read the array? Already we have written one function, and what is the function that we have written it? It is read array. Needless to explain this function, we say read array. Which array we want to read it? A. And how many array elements are there? There are n array elements. Now assume that the value of n is 6, and what will do? The scope of read array gets activated. All those things I said it already. And let the array elements be, let the array elements be 16, 17, 5, 3, 6 and 2. Let this be the array elements. Is that okay? Now after you read the array, to display the array or not, it is not mandatory. If you want to display the array, you can display the array as well. And the next thing that we want to do is find the leaders. Now say me, how many leaders are there in this array? 1, 17 is a leader, 6 is a leader, that is the second leader, and 2 is a leader, that is the third leader. Now there are 3 leaders. There might be 4 leaders. There might be n leaders in the array. When there can be n leaders in the array? If the array is in descending order, there will be n leaders in an array. Now how many value a function can return? A function can return maximum of 1 value. Now what we do, what should be the return type of the void find leaders function? What should be the return type of find leaders? If I say one function called as find leaders, what should be the return type of find leaders? It should be void, because a function can return only 1 value. I say find leaders of a comma n because the function does not return anything. We say return type as void and return 0, stop the main. And I want you to write appropriately the prototype of read array and the find leaders function. Is that okay? Please pause the video and make a note of it. Then we will see how do we write the find leaders function. Thank you. Let us see how do we find the leaders of an array. Now suppose this is the array 16, 17, 5, 6, 3 and 2. We know that an element is called as leader if there exists no element greater to it on the RHS subarray. Now let us write the function to begin with, and I say void because the return type is void. A function can return only 1 value. I cannot return the value here. And let me say the function name as find leader, as I already said it. What is the first parameter? Integer 1 dimensional array. And what is the next parameter? It is the number of elements, integer n, and the number of elements, integer n. Is that okay? Now how do we solve this? There are 2 ways of solving this. I will say both the ways so that you understand how do we solve the problems. Now let me consider 16 as leader. Initially what I do, I take the value of I to be 0. Initially I take the value of I to be 0 because each and every element I want to find it is leader or not. And I assume that 16 is leader. Let us assume that 16 is leader. To begin with, let us assume 16 is leader to begin with. Let us assume 16 is leader to begin with. Now, I want to search all the elements on the RHS subarray, because what is leader definition? There should not be any element greater to it on the RHS. That means I need to search only on the RHS. And let us take one more index and let me call it as j, and j starts from 1. That means for 16 I need to search all the elements on the RHS. Now you compare, is 16 greater than 17? No. Or is 16 less than 17? Yes, 16 is less than 17. What we are doing? We are comparing, is 16 less than 17? Now say me, how do you get 16? If the array name is A, you get 16 as A of I. Is A of I less than A of j? Yes, A of I is less than A of j. Now if A of I is less than A of j, say me, can 16 be the leader? 16 cannot be the leader, and we conclude over here that we are assuming, and we say that 16 is not a leader. 16 is not a leader, and we do not display it. Is that okay? Yeah. Now let us do for the element 17. Now I represents the current element. What does I represents? The current element. Now let me say I is equal to 1. That means you have to say I plus plus. And again what we do, we assume 17 is leader. That is how we begin. I have to do some assumption, and I assume 17 is leader. Now for I equal to 1, I have to search on the RHS subarray. That means initially the value of I was 0 and searching began from j equal to 1. Now the value of I equal to 1. What should be the value of j, you say me? The value of j means it should be 2, because you have to search on the RHS subarray. Now this is the value of j is equal to 2. Now again you compare. Is A of I less than A of j? Now the condition is false. Now what is A of I? It is 17. And what is A of j? It is 5. 17 less than 5, it is false. Now can you conclude that 17 is leader? Yes, any. Can you conclude that 17 is leader? No, because there should not be any element greater on RHS. There might be some element called as 60. Did you check the 60 with 17? No, you cannot just conclude it. That means I need to go till end and conclude that it is leader or not. Hence, the value of I should be 17. Alright, I is pointing to 17. Sorry, the value of I is 1. It is pointing to 17. I cannot change the value of I. Now I say j plus plus, the value of j becomes 3. Now again I compare a of I. Is it less than a of j? Is a of I less than a of j? Again it is false, because 17 less than 6 is false. Can I conclude at this point that 17 is a leader? No, because there are still 2 more elements that I need to compare with. Therefore, I say j plus plus, the value of j becomes 4. Again I compare a of I less than a of j. Again this condition happens to be false, because 17 less than 3 is false. Go to the next element and we say j plus plus, the value of j will become 5. Now you compare, is a of I less than a of j? Is a of I less than a of j? Again this condition is false. Again you say j plus plus, and when you say j plus plus, j becomes 6. There is no 6th index, and that means 17 is not less than any elements on RHS, which also means there do not exist any element greater than 17 on RHS subarray. Therefore, our assumption of 17 being leader is true. Therefore, our assumption of 17 being leader is true, and what we do, we display 17 as the answer. We display 17 as the answer. Okay, next time what you do, can anyone say? We say I plus plus, the value of I will become 2. Now, where I should search? Shall I search 16 and 17? No, because you have to search on the RHS only. Hence, the value of j starts from 3. Now, what shall I write? If the value of I is 2, the value of j starts from 3. Now, again you compare, is a of I less than a of j? Now, again you have to assume phi is leader. Again you have to assume phi is leader. I did not write that. That's okay. A of I less than a of j. The condition is true. That means assumption of phi being leader is false, because there exists an element greater than phi on the RHS subarray. On the RHS subarray. Therefore, phi cannot be the leader. You stop the procedure then and there. Now, let us, I have to take over here. Now the value of I is 3 and the value of j starts from 4. Again you compare. Now if the value of I is 3, j starts from what? 4. Now you might have understood it. 6 less than 3, it is false. J plus plus 5, 6 less than 2, the condition is false. There is no element left now. That means 6 is greater than all the elements on the RHS. Hence we display 6. Next we say I plus plus, the value of I becomes 4, and again the value of j should start from 5, because you want to search on RHS. Now if I is equal to 4, the value of j starts from 5. Now again you compare, is 3 less than 2? The condition is false. You say j plus plus, is there any element on the RHS? No element on the RHS. Therefore 3 is the leader of an array. Now you say I plus plus, the value of I is 5. Is there any element on RHS? No. And I said the RHS is the leader. RHS is the leader. This is how we find the leaders of an array. Now after this explanation, again I want you to pause the video right over here and try to write the program for leaders of an array. Thank you. Let us write the code for the leaders of an array. Now what we did, we assumed that the first element is the leader. I have somewhat changed this array. We assumed that the first element is the leader, and I begin from I equal 0 till the last element, that is I equal 5. Hence, how do we write the code here? How do I write the code? I say for the value of I, we start from 0 and we say I less than n and I plus plus and I plus plus. Now initially the value of I is 0. Now what I need to do, I need to assume that the 16 is leader. Now how do I assume that 16 is leader? How do I assume that 16 is leader? Now let me use some variable called as L, and I say L is equal to 1. That is how I assume. If the value of L is 1, that means the particular element, now what is the particular element here? I equal to 0 means 16 is leader. Is that okay? L equal to 1 means that particular element is leader, and if I say the value of L is 0, it means that particular element is not a leader. That is our assumption. This is our assumption, and from this we are going to solve the question. Now initially what we do, we assume that 16 is leader. Therefore what shall I write here? I shall say L is equal to 1 and I assume that 16 is leader. How do I know that it is 16? Because the value of I is 0, and what is the value there at the index 0? It is 16. Now we have to search all the elements on the RHS subarray. Now this is the RHS subarray. Now see here, if the value of I is 0, we are beginning with 1, we are beginning with 2, 3, we are beginning with 4. In general, if it is I, we begin J with what? Yes, say me. We begin J with what? Yes, we begin J with what? It is I plus 1. Therefore, I say for J is equal to I plus 1, I have to search all the elements on RHS. Therefore, it is J less than N and J plus plus. Therefore, it is J less than N and J plus plus. Now, initially, what is the value of I? It is 0. And what is the value of J? The value of J is 1. Now, I have to compare. Is A of I less than A of J? If it is true, that means 16 cannot be a leader. Assume that it is 50. Assume that it is 50. Therefore, what shall I write over here? I shall write if, say me, A of I is less than A of J. Now, what is A of I? 16. What is A of J? It is 50. Is 16 less than 50? Yes, 16 is less than 50. Can 16 be the leader? No. And if it is not a leader, what should I make the value of L to be? What shall I make the value of L to be? I shall make the value of L to be 0, saying that it's no longer a leader boss. Now, if 16 is not a leader, shall I go on continuing and searching with all the elements on the RHS? No, because anyway I know that there exists at least one element on the RHS. Therefore, I need to stop the loop. And how do I come out of the loop? Yes, how do we come out of the loop? We write the break statement. Very good. We write the break statement, and this is the end of if and this is the end of for. Now say me, whenever I write break, from which loop it will come out? From the jth loop it will come out. Now after I come out of the jth loop, I have two options. Is the value of L is 0, it means it is not a leader. If the value of L is 1, it means it is a leader, and the question is display the leaders. Therefore, I shall write here if the value of L is equal 1. Now, what is the value of L? The value of L is 0. 0 equal 1 is false. Therefore, 16 cannot be the leader. Now, if L is 1, what to do? We will see it in some time. As of now, I put semicolon. That means I do not want to do anything. Is that okay? Now, again I say I plus plus. Now, the value of I will become 1. This is where the value of I will become. Now, again I assume that 50 is a leader. And how do I assume that? And I say L is equal to 1. 50. J is equal to I plus 1. The value of J will start from 2. 2 less than N? Yes, 2 is less than N. Now, compare A of I. What is A of I? 50. A of J, 17. Is 50 less than 17? No, do not execute this. You say J plus plus. The value of J will become 3. Again you compare A of I 50, A of J 3. Is 50 less than 3? No, do not execute this. Again you say J plus plus. J will become 4. Again you compare A of I less than A of J. 50 less than 6? No, J plus plus 5. Now 5 less than 6, yes. A of I is 50, A of J is 2, 50 less than 2, no, do not execute this. J plus plus, the value of J will become 6, 6 less than 6 is false. You come out. Now what is the value of L? It is 1. 1 equal to 1? Yes, 1 is equal to 1. Now what does it mean? It means that 50 is a leader. And how do I display 50? How do I display 50? We say printf %d you can give a new line if you want, or a space, whatever it is there in the HackerRank, and we say a of I. Now the value of I is 1, a of 1 is 50, it displays 50, again it says I plus plus, I becomes 2, now it will check for 17 being leader or not. Similarly, you trace it for each and every element of an array, you will get it, and declare all the undeclared variables like I, L, J, whatever it is, I have used it. This is the way we find leaders of an array or not. This is method 1. We have one more method I am going to discuss as well, and you have to write the code yourself for that method. Thank you. Now let us see the method 2 of finding the leaders. I am saying this method 2 because I want you to know how do you think in the other way as well. Okay, now what is a leader? An element is called as leader if there exists no element greater to it on the RHS. Now that means, can I start comparing from the RHS? The question is, can I start comparing from the RHS? Yes. Now how many elements are there? There are 6 elements. There are 6 elements. Now I know that the rightmost element is always leader. And how do you get the rightmost element? How do you get the rightmost element? We say a of n minus 1. Because the index starts from 0 and index goes up to n minus 1. This is how you get the rightmost index. And let me call this as the maximum element. Now what does it mean? It means that I am starting searching from the RHS. And when I start searching from the RHS, the maximum element till this point of time is 2. Because there exists no element greater. Greater means max. Hence, what shall I write over here? I shall say print the value of max. Hence, you print 2 as a leader. Yes, 2 is a leader. Now you compare. Now what is the value of max? The value of max is 2. Now, you compare. Is 6 greater than max? Yes, 6 is greater than max. That means, what does this max represents? Max represents the maximum of elements of the RHS. As I said, explained to the maximum of array from the LHS, we are finding the maximum from the RHS now. Now see here, is 6 greater than the maximum? Yes, it means 6 is greater than all the elements of the RHS. Are you getting it? Therefore, we say maximum is 6 and we display 6 as the leader. Is that okay? Now it means till this point of time, maximum is 6. Now, will you compare 3 with 6 as well as 2? No, you compare 3 with maximum. If 3 is greater than maximum of RHS, 3 is greater than all the elements of the RHS. Are you getting it? Now you compare. Is 3 greater than 6? No, that means 3 cannot be leader because maximum of this subarray is 6. There is some element 6 somewhere which is there, therefore 3 cannot be leader. Hence the maximum till this point of time is 6. Now again you compare, is 17 greater than 6? Will you compare each and every element 17 and 3, 17 and 6, 17 and 2? No, we know that the maximum of this set is 6. Hence I can only compare 17 and 6. Therefore we compare, is 17 greater than maximum? Yes, 17 is greater than maximum. Therefore we update maximum to 17 and we display 17 as the leader of the array. Now it means maximum till this point of time is 17. Is that okay? Now, will you compare 50 with all the elements on the RHS? No, you just compare 50 with the maximum of this set. And what is the maximum of this set? 17. And where it is stored? Max. Compare. Is 50 greater than max? Yes. Therefore, you have to update max as 50 and display 50. It means the maximum of this set is 50. Now, if it is any element which is greater than 50, then that particular element will be what? The leader of an array. Now, you compare. Is 60 greater than the maximum of RHS, which is 50? No. That means 16 cannot be leader. That means this complete set is represented by 50 again. Hence, we stop because we have compared all the elements. Now we are coming from the RHS. Hence, the leaders of this array is 2, 6, 17 and 50. 50, 2, 6, 17 and 50. Is that okay? I want you to write the code for this explanation yourself. Okay, thank you friends for watching this video. This is how we find the leaders of the array. Thank you.